For questions after 3, that means 3, 4, 5, and 6, please make the reactant as well as the product. So you have to start with benzyl alcohol and then to benzoic acid. That will help you more in order to get what reagents are to be used. Okay. Just don't think that blindly you can write what are the reagents without drawing the structures. Please draw the structures of the reactant and also the product. Okay, so if you're done, please start sending the answers. Please start sending the answers. Okay, I've got the answer from Khalid. Very good, Khalid. Just something is missing in the sixth one. Everything seems fine, Khalid. Very good. Yeah, very good. Correct. I'm waiting for others. Just 2 minutes more, okay? Please start sending the answers. Come on, guys. Please send the answers. आप लोग इतना लेट करते हैं फिर से. Just 1 more minute. 6 questions only. Yes, Salman. Very good. Correct. Okay. Thanks. Only Salman and Khalid has sent. No one else. What happened, guys? Okay, Nabila Ahmed joined late. Astha, what about you? Astha,
Yes, sir.
not done.
Sir, I didn't complete all 3 questions. I did the rest. I'm fine.
So when I said 10 minutes, then you have to send it under 10 minutes, right? ये बात हम कई दफा जमाने से बोलते आ रहे हैं और आप लोग को
I'll send the ones I did.
हाँ send whatever you have done, please send me, guys. First one correct, second one correct, third one correct, fourth one no. So this is Saif. Matthew. First one fine, second one, no, I don't know what you have written. Please write properly. Third one, no. Last class was only, है ना? Nothing else, only last class. Okay. Asta, why you have written so many reagents? You can just write one. No need to write so many. Okay, Asta. Once you have done, those are correct, Samira. First one, this is only one, na? Okay, okay. 1, 2, 3 you have answered. Yes, Samira, correct. Minashi. Okay. And okay, fine. Minashi. Matthew wrote PDC. Where did you write Matthew PDC? Anya absent now. Hishma, what happened to you?
Sir, you
Hishma, you
said
have not.
you couldn't read what I wrote, right? That one.
Okay. Hania, can you please turn your mic on?
Yes, sir.
Is what you have written, is that a reagent? In the first two questions, tell me.
No.
No, no, it's a process that we are just showing that oxidation is happening, right?
Yeah.
Okay, fine. Now in the third one, you have written the benzyl alcohol correctly. The figure is right.
Yeah,
But what is
yeah.
you have to write it? सवाल okay, अभी तक जिसने भेज दिया प्लीज okay, that's fine. Don't send me any more answers. Time भी तो जाता है, आपको प्लीज का ख्याल ही नहीं है. I almost spent almost 20 minutes for the last class only. सवाल 1 correct, 2 correct, 3 correct, 4 correct. So okay. Now see here, oxidation of 1 degree alcohol to carboxylic acid. Then we are going to use any strong oxidizing agent, such as we can use K2Cr2O7, K-MnO4, H2Cr4, and those things. Okay. Now oxidation of 1 degree alcohol to aldehyde, PDC, PCC, or Collins reagent. So in NCERT, PCC is there, so you'll also write PCC only. Okay. Benzyl alcohol. So benzyl alcohol, I am glad that most of you have written it rightly. That this is benzyl alcohol. Okay, and this is phenol. So this is not benzyl alcohol. If somebody was thinking about that, please refrain from thinking about that. Here also, we are going to convert alcohol to carboxylic acid. So we are going to use again, let us say KMnO4. Dehydration of, now again, dehydration, we use H2SO4, right? H2SO4 plus C. Dehydration. So we have propane 2-ol in the presence of H plus from H2SO4, and some heat, you will be getting prop1E. Next, we have here butane 2-on to butane 2-ol. First of all, you have to identify that it is a ketone, and this is butane 2-ol OH. So this can be converted only through CrO3. Yeah, you can also use here. Oh no, sorry, my bad. LiAlH4 or NaBH4. I was thinking about the other thing. Or NaBH4. Any of the reducing agents. Now propane to propane 2-ol. Acidic hydration. Okay, acidic hydration. So here you can use NaBH4 also and LiLH4 also. Here you are going to use propene to H plus in the presence of H2O. So that's it. Now, in the last class we were doing acidic nature of phenols. Acidic character. So we have written about alcohol, phenols. Okay. Now we are going to write about the substituted phenols and different type of substituted phenols. Okay. So please write. And we'll look into this in detail now. acidic character of substituted phenols. Now here we know from our last discussion on acidic nature of alcohol, we concluded that in substituted phenols we'll have -M, then followed by -I, followed by none, and then followed by +I, and followed by +M. So this was our conclusion from the acidic character of alcohol discussion. And now we will grow on to this particular order that we have, the trend that we saw. And first of all, we'll discuss about the different types of nitrophenols. So please write number 1, nitrophenols. Now the different type of nitrophenols that you can have is p-nitrophenol, which will have the highest acidic character, followed by, I will explain why is the reason, orthonitrophenol, followed by metanitrophenol, and all of these will be having higher acidic character than phenol. Right, this all will have highest acidic character than phenol. Why? Because now you will label this as para is what? -M, ortho is also -M, but meta is -I, and as we can see -M, and then, but why is in the ortho lesser than para? You'll write a reason. Orthonitrophenol is slightly less acidic than p-nitrophenol due to the formation of intramolecular hydrogen bonding which makes the liberation of proton difficult. So you have OH like something like this, and nitro group is double bond O. Second, we have single bond O and double bond O is here, and these hydrogen will form a intermolecular hydrogen bond with the nitro group here, and that is why what happens, the liberation of this H plus. Now this hydrogen is bounded with oxygen and oxygen, so that is why it does not leave the O nitrophenol. Okay, so this is the intra means between the same molecule. In the same molecule, you are having hydrogen bond. Intramolecular hydrogen bond. After this, we are going to write cresols. Now, cresols are all electron donating group. That is why all of them will have lesser acidic character than phenol. And the least will be with, after phenol, we'll have the metacresol because it is +I, followed by paracresol, and then followed by orthocresol. Okay, orthocresol. So as we can see, phenol is none. M cresol is plus I, followed by P cresol is plus M as well as plus I. Okay. And O cresol is also plus M as well as plus I. So generally we only see plus M, and when there is plus I also, there also we only see plus M only, because plus M is more dominant. But when I have to compare two different groups which are having two different molecules which are having plus M and plus I both, then in that case what I'm going to do, I'm going to write that, okay, fine, this is plus M, this is plus I, this is also plus M, this is also plus I, but this ortho plus I is what it is nearer to, as you can see. This is my phenol, and we have the CH3 group here. Now this CH3 group can very easily push the electron towards the oxygen atom because it is nearer to the OH group. So you'll write here, this is more due to because it's near to OH. Okay, and that is why it is least acidic. Because if CH3 is giving electrons, then the OH bond will be becoming less and less polar. And that is why the H will not be liberated easily. The bond will be strong. When the bond is less polar, it is strong. Okay, you can also write the structure of P cresol. So as you can see, the CH3 is far away, and that's why it cannot show its effects through plus I very much. That is why the plus I is more effective in the orthocresol. After this, you are going to write the third, aminophenols and methoxyphenols. Okay, so aminophenols and methoxyphenols are what? Amino is NH2 and methoxy is OCH3. Now both of these groups, they have similar type of effect because we have here lone pair electrons on nitrogen, lone pair electrons on oxygen. But as we know, nitrogen, this lone pair, it is having plus M, but due to nitrogen it will be having minus I because it is more electronegative. Here also, because of lone pair, it will be giving me plus M, but due to this oxygen, which is highly electronegative, it is going to give me minus I. Okay, it is going to give me minus I. And now we all know that the minus I of methoxy, it is more than minus I of amino because oxygen is more electronegative. Oxygen is more electronegative. Okay, so first of all, we will look here. Now, because we are going to consider only minus I am going to take the meta positions. So I will write here, let us say M-methoxyphenol. This will have the highest acidic character, followed by M-aminophenol. Okay, so M-methoxyphenol and M-aminophenol, right? Next one, okay, and this both of these M and M-aminophenol, this will be having higher acidic character than phenol because these only show only minus I. Only minus I, and this is none. But when we are going to compare the M, O, and P, then we will write it like this: M-methoxyphenol will be having highest. This will be followed by phenol, and then this after this phenol we will get O-methoxyphenol. यहाँ पे आपके पास O-methoxyphenol, followed by P-methoxyphenol. So here we have minus I, here we have none, and in O-methoxyphenol, what do we have? We have plus M. That is why it is after phenol, but it is before P because it has minus I, and minus I is favorable for acidic character, and this is nearer to OH because ortho is near to OH. Right? Here we also have plus M, and it also has minus I, and both of them have plus M and minus I, but the minus I of ortho is more, minus I of ortho is more effective because it is nearer to OH. So write this point. About aminophenols and methoxyphenols. Then we'll look at halophenols, fourth one. Please write. Halogens show plus M and minus I. But minus I is more dominant. Minus I is more dominant. So in general, when we talk about phenol and halophenols, halophenols will have higher acidic character. So first point that we are going to write is regarding halophenols. So halophenol, any halophenol will have higher acidic character than phenol. Now we'll look at the different types of halophenol. We'll look at different types of halophenol. So first of all, we'll talk about the positions. So let us suppose we have M halophenol and P halophenol and O halophenol. Now in this case, ortho halophenol will be highest because it is nearest. All of them are showing minus I, ortho halophenol, followed by meta halophenol, followed by para halophenol. So meta will be having minus I, and this also will be having minus I. But this is the order. Why? Due to distance. You know that this is nearest and this is farthest. And whatever is nearest, minus I can show its effect more effectively there. So this is the second. And the third point you will write regarding the different halophenols in terms of halogen atom. So the highest is of chlorophenol, and we'll write for ortho only. Ortho chlorophenol is highest, followed by ortho bromophenol, followed by ortho iodophenol, and at last we have orthofluorophenol. Now this order till here this is due to electronegativity. But orthohalophenol, it is lower than all the other halogen atoms. Why? Due to formation of intramolecular hydrogen bond. Please write this down. Let me know when you're done. Please raise your hand when you're done.
Sir, your minus I effect means electron withdrawing of it or electron releasing?
Electron withdrawing. Minus is always electron withdrawing.
Sir, the M effect means
Mesomeric effect.
like it's because of resonance structures or
Yeah, correct. Resonance is actually, it is a phenomena, and mesomeric effect, it tells you about the movement of electron towards or away from the main carbon ring, or whatever your choice of atom is. For example, our choice of atom, what we are looking here is the oxygen atom, right? So what is happening to that oxygen atom, whether the electrons are moving towards the oxygen atom or they're moving away from the oxygen atom, that we say in terms of plus M. Resonance is just a phenomena. The delocalization of electrons or resonance, but the direction it is decided, and it is denoted by plus M or minus M. You got the difference between these two, mesomeric and resonance?
yes, sir. And plus M means it is moving towards or away, sir.
So it is giving towards. It is a donating effect, releasing effect. So see, choice of atom, it matters a lot actually. Okay, choice of matter actually matters a lot. For example, if you just sit on halogen atom, and then you will see that from the halogen atoms, electrons are moving away, right? But when you sit on oxygen atom, you will see that electrons are coming to me. So you will say that so many time. So first of all, you have to see what is happening. And for example, halogen, if you sit on halogen atom, you're seeing that electrons are moving away from me, right? Because it is really, halogen atom is plus M, and it is giving electrons to the mesomeric effect. But here you have to just look at the oxygen atom, what is happening, whether the group that we have added, it is giving electrons or it is taking electrons from the oxygen atom. Done, guys? Yes, no, please tell me. क्या नहीं लिखा है क्या किसी ने? अच्छा, oh, everyone has raised hand. Sorry, I did not get any notification. Waiting for Khalid, Mohammed Saif, and Nabil Ahmed. Waiting for, okay, only Nabil Ahmed. Waiting for Nabil Ahmed.
Sir, I'm raising hand, sir.
Where are you raising hand? At your home?
Yes, sir.
Oh, there is one more Nabil Ahmed, na, actually. Okay, fine. Sorry, there is one more. Is that Nabil Khan? Or? Okay, I don't know. Fine, actually. If you're not done, just let me know. I think everyone is done. Fair. Now we'll write two simple reactions about phenol. Write the second reaction. A reaction with zinc dust. Now in this reaction, it's very simple reaction. You will take phenol and you will blow zinc over it with some heat, and it will magically convert this to benzene ring. Plus it will give ZNO. Then the third one. Oxidation of phenols. So in oxidation of phenol, we'll take phenol. Oops, sorry. And here we have to use strong oxidizing agent. And also in the presence of H2SO4, Na2Cr2O7 or K2Cr2O7, KMnO4, anything else, and 2O7 in the presence of H2SO4 is going to give you benzoquinone. Everyone, please write the next topic: electrophilic substitution of phenol. Electrophilic substitution of phenols. In this, first of all, you will write the heading.
Sir, can you go a little up?
Yeah, sure. By the way, Asta, did you complete haloalic and halorine?
No, sir, I haven't.
Okay. You said that you'd had some difficulty in Markovnikov and anti-Markovnikov. Is that clear now?
Yes, sir.
Okay.
Sir, today's chapter test is like for the full chapter, no?
Full
Hello.
chapter. Yeah, full chapter.
Done, sir.
Okay. Electrophilic substitution of phenols. Write the first one, bromination. Okay. So bromination can be done in the presence of two different solvents. So we'll see the effect of solvent in this case. So we have phenol. Please don't write anything. And we use Br2. Now here this oxygen atom, it is having lone pair electrons. And what it is doing, it is activating the ring so much that Br2 does not need any Lewis acid, as in the case of haloarenes and in the case of haloarenes. Okay, so Br2 can directly react in the presence of CS2, and CS2 is a non-polar solution, a non-polar solvent, because carbon, it has a double bond with sulfur and a double bond with sulfur. Sulfur is more electronegative, so there will be a dipole like this. And then sulfur is more electronegative, there will be a dipole like this. Now both of these dipole will be cancelling each other out. That is why CS2 carbon disulfide, it is not a polar solvent, it is a non-polar solvent. In the presence of non-polar solvent, it gives you two products, orthobromophenol and parabromophenol. Okay, we have OH here and Br here, and we have, so if I write OH here and Br here, is there any problem? I hope all of you can identify now. This is also para.
Yes, sir.
Yes,
Sure.
no? Okay, very good. Oh, bromophenol. And p-bromophenol. Now, in the presence of water, now which is a better acid, phenol or water?
Phenol.
Phenol is a better acid. Very good. Now, if phenol is a better acid, it will give its H plus ion, right? It will lose its H plus ion, and this oxygen will get negative charge. Now, this negative charge will be activating the ortho and para position, and it will be activating so much so that in the presence of, sorry, यहाँ पे H2 नहीं लिखना था, my bad. I should write here Br2, and above the arrow I have to write. Here I have to write H2O. So in the presence of water, that means if I take bromine water, then I will be getting OH and 2,4,6 tribromophenol.
Sir, when you are saying hydrolysis, what should be mentioned on the arrows, sir? Because some places they're given H3O plus, some places they're given H2O, some places they're given H plus or OH minus.
For no, OH minus, but they will give you condition acidic hydrolysis or just hydrolysis. जब भी आप उसमें ना ये देख सकते हैं what product you have to make. For example, you will only tell me if I have something like this and I want to make phenol. What should I add?
H plus.
Yeah, correct. Hana?
And sometimes H3O plus or H2O is given. So which one do we use? I cannot mention whether it is acidic or
Okay, okay. Wait a second. What is the meaning of H plus? Tell me now. What is the meaning of H plus?
hydrogen ion.
Hydrogen ion. That means there is no electron in the hydrogen atom, right?
Yes, sir.
That means it is only a proton, correct?
Yes, sir.
So now there are debates whether a proton can exist on its own. I mean, whether it can exist or not exist. That's why when we write H3O plus, that means it is acid. This H plus is equivalent to H3O plus. Got it?
Yes, sir.
Okay. Now sometimes they will just write H2O, but that is very least of the cases. They will write just H2O. But when they are doing some reactions now, for example, they also write then H plus, or if it is hydrolysis in the presence of base, they would write OH negative. But base के presence में बहुत कम है आपके इसमें. It's not there till now. Base के presence में सिर्फ आपके पास hydroboration oxidation में था. In that we are doing H2O2, and that also is hydroboration oxidation. Okay. If you are confused, just write H2O. Okay, so here we can write 2 points.
Sir, and for bromine water, some places they've mentioned bromine separately in reactants, and in the arrow also they mentioned bromine with H2O. And sometimes instead of H2O they put ethanol, but in the description they put bromine water.
Yeah, so it is a polar solvent. That is the only thing that you have to remember. Polar solvent. It is not only polar, it's hydrogen bonding solvents. Ethanol and water, they will behave same now. What is changing here? Instead of hydrogen, we have just C2H5OH. Okay. आपके इसमें नहीं है लेकिन. You don't have to worry about it now. You understood that this is a hydrogen bonded
Yes, sir.
solvent? So that's it. Same ethanol is also hydrogen bonded solvent, correct?
Yes, sir.
So then only in both the cases you will be getting 2,4,6 tribromophenol. Okay, so main issue is with whether if it is non-polar, then you are going to get O-bromophenol and P-bromophenol. If you see something else, then these are the only two cases. And I think you can classify very easily there. Right, in the presence of H2O, the phenol converts to phenoxide ion, and the negative charge on oxygen activates the ring.
Sir, what did you write after that one? Phenol converts to?
Phenoxide. Sorry, phenoxide ion charges activates the ring so much that it increases electron density at ortho and para position, forming tri-substituted phenols.
Sir, can you show from the starting of bromination?
Okay, Salman.
Sir, what is the meaning of activating and deactivating?
Activating means increase in the electron density at all the ortho and para position, and deactivating means the decrease in the electron density at ortho and para position.
And sir, there's one thing called diisobutyl aluminum hydride. Sir, for that,
Divalent.
yes, sir. For that, in
Hmm.
some reactions they put ALH, IBU twice, and some places they put dipalH the whole. So which one is dipalH, sir?
If you're saying they use both of them, then both are Divalent, na?
So we can use them interchangeably, or
People are using it interchangeably. Books are using it interchangeably. Nabil Ahmed, tell me.
yes, sir. Just in the above
Yeah.
reaction,
Sorry.
just in one reaction above they said dipalH. Next reaction they used ALH, IBU the whole twice.
So I'm asking, books are following both of them, na?
Yes, sir.
Books are using them interchangeably. Can we follow the book? Yes,
sir.
Nabil. You have your answer.
Yes, sir.
Thank you. Okay. Right, next, nitration. Now, if we have simple phenol and we use dilute nitric acid, this is going to give me ortho substituted NO2 and para substituted NO2. This is major product. The para is major product in the above cases also. Okay. Now, one point here you are going to write is, as we have seen already, that this O-nitrophenol has intramolecular hydrogen bond. What will happen if it has O-nitrophenol has intramolecular hydrogen bond? Then it will have, therefore, it has lower boiling point than P-nitrophenol. And P-nitrophenol has intermolecular hydrogen bond intermolecular hydrogen bond. That is, it has higher boiling point than O-nitrophenol. So we can write for O-nitrophenol once again. We have oxygen and then we have hydrogen here, hydrogen and oxygen. So this hydrogen and oxygen, they can form intramolecular hydrogen bond. It will have one more oxygen group like this. Now for P-nitrophenol, you can write something like this. We have nitrogen atom, double bond, single bond. And then we have hydrogen atoms, OH of some other phenol, nitrophenol. And we have NO2. So these are what? Both of these are P-nitrophenol. And you can see that they can have, two molecules can have hydrogen bond. If the two molecules are sticking together more consistently in P-nitrophenol, then breaking them will be difficult, okay, because they're interacting and they're attracted towards each other through the hydrogen bonding. So they're sticking together through the hydrogen bonding, and that is why breaking them apart will be difficult. And hence, the O-nitrophenol, it has lower boiling point than P-nitrophenol. Okay. So orthonitrophenol has intramolecular hydrogen bonding, but does not give anything for the orthonitrophenol, because the hydrogen bonding is just completing inside one molecule. But P-nitrophenol, two molecules are interacting. Okay, you write next point. Since O-nitrophenol is more volatile means a substance which can easily evaporate or boil off rather, not evaporate, more volatile. Since O-nitrophenol is more volatile than P-nitrophenol, they can be separated using steam distillation. Please think about azeotropes. In that case, I told you guys what is distillation and how can we separate molecules or separate different substances using distillation. In distillation, the main principle is that there should be a difference in the boiling point. If there's a difference in boiling point in the mixture, one of the components will boil off first, then it will condense, and then it will be in a pure form. And whatever is remaining here, that will be in a pure form. That will be substance B. Okay, so this is how we do distillation. The main principle of distillation is that there should be a difference in the boiling points. And we have here between O-nitrophenol and P-nitrophenol. O-nitrophenol is more volatile. It will boil off first, and then we can separate first of all O-nitrophenol, then we can boil the P-nitrophenol, and then we can get the P-nitrophenol. Okay, so there is a question also like this, that how can you separate O-nitrophenol and P-nitrophenol? Then you will write, since O-nitrophenol is more volatile than P-nitrophenol due to the presence of intramolecular hydrogen bonding in O-nitrophenol and intermolecular hydrogen bonding in P-nitrophenol, these can be separated using steam distillation. Next, you will write, we have the same phenol. Now we are going to react this in the presence of concentrated HNO3. Now, this will be done in the presence of H2SO4. And we are going to get tri-substituted product. This is 2,4,6 trinitro. Now, also known as picric acid. Next topic, you will write here, modern method of picric acid. Modern MOP लिख लीजिए आप, modern method of preparation. If you look inside NCERT, you won't find this reaction because NCERT has asked you guys to give the reactions. So they have written in a text form as a paragraph that what is going to happen. So they start with, we will do sulfonation of phenol, and then on further treating this with nitric acid, we get picric acid in more yield. So we'll start with phenol, and we will do sulfonation. And please see, they have not mentioned, NCERT has not mentioned sulfonation as a topic for electrophilic substitution of phenol, but they have given this modern method of picric acid in text. So we have here concentrated H2SO4. It is going to give me two products. One is orthohydroxysulfonic acid, right? So you'll have your SO3H, and here I will have the para substituted OH and SO3H. Now, the mixture here, all of these will be reacted with concentrated HNO3. And you are going to get the picric acid. So you guys are done. Please write these questions. Okay. So let us see the questions.
Sir, could you show the reaction again?
Sure. Let me know when you're done. Okay.
Done, sir.
Done. Okay. Now, first of all, they're asking, write the structures of major product expected from the following reactions: mononitration of 3-methylphenol, dinitration of 3-methylphenol, and mononitration of phenyl methanoate. So we have first 3-methylphenol. Let us understand the structure first of all for 3-methylphenol. So we have here let me draw the whole structure. Oops, sorry. So we have here O, we have here H, and in the ortho position, that means okay, mononitration of 3-methylphenol, 1, 2, 3. Carbon, 1 hydrogen, 2 hydrogen, and 3 hydrogen. Okay. Now this space here, it is very narrow space. Okay. So we have here 3 positions in which you can do the attack. First of all, we have, let us suppose this position, that is ortho. What happened? Okay. So this position, which is ortho. Okay. And then this is the position which is ortho to hydroxy, but it is para to methyl. But it is para to methyl. Then we have this group here, this position here, which is para to hydroxy, and it is ortho to CH3. And we have, let us say, this group also, which is meta to both of them. Okay, so we obviously know that the mononitration means what we have to add. We have to add only one nitrogen group, only one nitrogen group. So we know that very easily that mononitration, this nitration, it will not happen here because it is meta to both of them, right? It is meta to both of them. And another thing is that it will not also happen in this case here. Why? Because we have 1 and 3 substituted phenol. We have 1 and 3 substituted benzene because we have a group in the first position and the third position, which makes us very sterically hindered. This whole region is very sterically hindered, and we cannot add a big group such as NO2. Okay, we cannot add this group from here. So attack cannot happen from this carbon atom. Now we can draw both the products. For mononitration, I will draw two products. So you will add nitrogen on this green carbon atom and then the blue carbon atom. Okay, so one product will be getting something like this, OH, CH3, nothing will happen to these. We'll get NO2 here, plus I will get NO2 here. Okay, so mononitration. We will be getting two products here. Next case is now here they're asking dienitation of 3-methylphenol. So we have the same methylphenol here, right? Here we have the same methylphenol. OH, CH3, and we are doing dienitation. That means two nitro group will be added. And we know that the two positions on which the nitro group will be added are these two positions. OH and CH3 as it is. One nitro group will be added here, and the other nitro group will be added here, and we have done dinitration. Is this clear? Yes or no? Please tell me. Is there any doubt with anyone? Please tell me now for the A and B. If you have doubt, please let me know now. Yes,
Sir, can you
Nabil.
explain again?
Which part? Tell me.
The second one, B.
Second one. Okay. So see, here we have 6 carbon atoms. 1, 2, 3, 4, 5, 6. Okay. Now you will, right? OH group and CH3 group. Both of these are plus M. Correct?
Yes.
So both of them will be doing reaction at, or they will be giving ortho para substituted product, correct? Right?
Yes.
Yes or no? Okay, fine. Now tell me, what are the position in which we can add nitro group? I have written now 1, 2, 3, 4, 5, 6. Can we add nitro group in the first position? Tell me. Sir?
No.
No. Can we add in the second position?
No.
Why no? Because it is?
Because it's ortho and para only.
So that is ortho position. Second one. Second carbon is the ortho position, right? Yes or no? It is ortho to OH also. It is ortho to CH3 also. Correct?
Yes.
So why we cannot add nitro group there? We cannot add the nitro group because
it'll be near to OH.
it will be near to OH and CH3. Nitro group cannot be attacked from that side because it is sterically hindered. वहाँ पे बहुत ज़्यादा atoms है ना, so we cannot do transfer of electrons, or groups cannot attack there. Got it? Yes or no?
Sir.
Okay, so it is between OH and CH3, and that is only one carbon atom. So it makes it very clumsy, and the nitro group cannot adjust in, and they cannot go inside that. Okay, and that is why we don't. That 2 position is also unreactive. That is unreactive due to steric hindrance. Okay, it is unreactive due to steric hindrance. Now, can we add on the third carbon atom?
No.
Why? Because CH3 is already there. What about the fourth carbon atom? Can we add there?
Yes.
Why? Because
it's free.
No.
It is in
Ortho
ortho
para
position also.
Ortho to CH3 and OH के pH para में. Please see this, and Saf, let me know, and others also. Please let me know if you can understand this when I say it is ortho to CH3 and para to OH. Fourth position. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
Anya, Astha, Heshma, Khalid, Matthew, Minashi.
Yes, sir.
Yeah, sir.
Yes,
Yes,
sir.
na? Okay, fine. Okay, that is why the fourth position is the reactive position. Then we look at the fifth position. Now, please tell me, guys, fifth position is dash to CH3, ortho, meta, or para? Please answer, guys. It is dash to CH3. The fifth position is?
Meta.
Meta.
It is, and it is dash to OH. Please answer, guys. Nabil, aap mat boliyega. And with respect to OH, very good, Saf. It is meta with respect to OH also. Okay. Now, that means the fifth position is unreactive because it is meta. What about the sixth position? Sixth position is dash to OH. With respect to OH, sixth position is dash, ortho, meta.
Ortho.
Very good. And with respect to CH3, it is?
Para.
That is why it is a reactive position. Okay, it is a reactive position. Hania, आपको समझ में आ रहा है? Is Hania here? Yeah, Hania is here. Yes, okay, fine. Now, and that is why dinitration means you have to add 2 nitro groups. And what are the position in which we can add nitro groups? 6 and 4. So we added nitro group on the 6th position and the 4th position. Got it, guys? Yes or no? Please tell me.
Yeah, sir.
Right now, in the A case, when mononitration was the given criteria, then we added nitro group once in the 6th position and then once in the 4th position, and we got 2 different types of what we can call this. This is a phenol, so this will be JKLM and methyl nitrophenol, right? So we got 2 different methyl nitrophenols. Now let us look at this phenyl methanoate. Now the structure here, first of all, we have methanoate. What is methanoate? Can anyone tell me what is methanoate? What is the meaning of methanoate? Okay, so we have if COOR, then this is known as ester, right? We have O8. Correct? Yes or no?
Yes, sir.
Now, what we are seeing, it is methanoate. Then this carbon is what?
CS3.
Yeah, very good. And we have phenyl, which is attached to oxygen atom. Oxygen, double bond C, and we have CS3. Okay, so we have this phenyl group attached to methanoate. Okay, phenyl group attached to methanoate. Now, here this oxygen atom, what is this? It is having lone pair electrons. It is having lone pair electrons. Okay, now lone pair electrons, that means it is electron donating, right? It is plus M. It is plus M group. So what are the position in which we can add nitro group? Please tell me. 1, 2, 3, 4, 5, and 6. Please tell me in the chat. Where can I add the nitro group? I have to do mono na. Yeah, mononitration. Where can I add the? In which of the places? 1 में, 2 में, 3 में, 4 में, 5 में, 6 में. Where can I add nitro group? Nabil, it is a electron donating group or it is a electron withdrawing group? Nabil?
Donating, sir.
Donating, na? So it will increase the electron density at, okay, fine, very good. It will increase the electron density where? At which positions? Astha, correct. हाँ बताइए.
Ortho and para, sir.
So why you are writing 3 and 5?
Sorry, sir.
Okay. Tell me, guys, where can we add? We have ortho para directing group now. Please answer, guys. Only Astha and Nabil has answered. Hania, Hishma, Khalid, Matthew, Minashi, Saif. इतने सारे students say, please answer. What are the positions in which I can add the nitro group? Start like this, please. अभी हमने पूरा सब कुछ बताया कि इवान में कर सकते नहीं कर सकते, कैसे सोचना है, नहीं सोचना है, सब कुछ बताया. फिर भी आपको हाँ करेक्ट मैथ्यू. Okay, Hishma, fine, correct. I'm still waiting, guys. Khalid, Salman, Nawal, Samaira. Samaira, what happened?
Sir, what's the question again? We have to
The
send
question
the
is-
product in group.
No, I have just asking where can we add the nitro group in the 2, 3, 4, 5, 6, or 1? Where can I add the nitro group? Yes, Khalid, correct. Please answer, guys. What happened? Hania? Hania, why can't we add in the 3rd position? Tell me, Hania. Hania, tell me, why can't we add in the 3rd position? Okay, Minashi.
It's metal.
Okay, so why can't we add in the 4th position? Yes, Hania.
It's
Why
para.
can't? It's para, so it is also para directing, right?
Yeah.
So Okay,
Okay.
got it?
Yeah,
Fine.
yes.
So we can add the nitro group in the second position, in the fourth position, as well as in the sixth position. But I hope all of you can see that I have a very bulky group here on the first carbon atom. So this CH3 group here, it will not be as condensed as like this. It will be okay, and it will be what this particular CH3, it can be this side also and this side also, and this will be moving because it is single bond here right now. It has partial double bond character, but it is essentially single bond. There can be some rotation allowed here. And that is why what is going to happen, this CH3 will be hindering the second and the sixth position. 1, 3, and 5 are already not activated. They don't have any electron density. So the only position left after the considering steric hindrance is the fourth position. So you have oxygen, C double bond O, CH3, and the nitro group will be added in this position, NO2, like this. Okay, so why are we not having any on the sixth and the second one? Because it is sterically hindered. Okay, so I hope we are done. The next reaction, that is very important reaction, Kolbe's reaction. Guys, यहाँ पे हमने कहीं पे भी नहीं लिखा है sterically hindered, but in your notes, because you have to understand. ठीक है, हमको तो आता है chemistry, right? You have to understand organic chemistry. You have to revise these things. That means you have to write somewhere in the note, this is sterically hindered. That is why we are not getting these and these products. Okay. So please write those things. Right, next, Kolbe's reaction. Please write here, when sodium phenoxide is heated, when sodium phenoxide is heated with CO2, at around 400 Kelvin and 4 to 7 atm pressure, sodium salicylate is formed. Sodium salicylate is formed, which on further acidification, which on further acidification gives salicylic acid. Okay, so we'll start with phenol, however, because we all know that if I have phenol, I react this with NaOH. It is going to give me ONA, sodium phenoxide. Now the reaction start. You have to react this with CO2 in the presence of high temperature and pressure. And here what we are going to get, here we actually first of all get OCOONA But then there is a rearrangement in which this complete COO group, CONA group, it transferred to the ortho position like this. And what do we get here? We get here a hydrogen. And here we get COONA. Okay, and this is sodium salicylate. Wait a second. यहाँ पे इसमें लिखिए sodium salicylate. Okay, and then on further acidification, that means you react this with dilute HCl. You are going to get salicylic acid. Instead of Na, you are going to get hydrogen atom. Done, guys? Done everybody answer? No, please tell me.
1 minute.
I hope you have written the text at least. Then you can write the mechanism. Okay, so I'll start here with sodium phenoxide ion only. Okay, I will start with sodium phenoxide ion. So in sodium phenoxide ion, I will be having O negative. Okay, now this O negative, it will move the electron here, and this electron will move here. And you will get one kind of resonance structure like this. Double bond O, negative charge here. Here you will get a double bond, here you will get a double bond. Okay, now what is going to happen here? You are going to have sodium atoms around, right? Sodium atoms, and there will be carbon dioxide. Now carbon dioxide is what? C double bond O and C double bond O. Right, now this carbon atom, it will be attacked by this negative charge, because see, carbon dioxide ion, this carbon dioxide atom, it is attached with oxygen, and here also oxygen. Both are very electronegative. That is why this will be having very highly electron poor carbon. It will attack like this. Leading to a formation of what are you going to get here? Here you are going to get double bond O, and this C double bond O, and then O negative, Na positive. And we have here hydrogen atom. Now this oxygen atom, it is very electronegative, and further it is having double bond. Okay, now what is it is going to do? It is going to abstract this hydrogen from here, leading to formation of. Now this hydrogen will leave the electrons here. You will get the benzene ring back, OH atom back, COONA, and then on further dilute HCl, we are going to get salicylic acid. Please write this down. Actually, this Na plus also, it has a very good role actually to play. It brings the COO, that is carbon dioxide, and the phenol molecules nearer. So you have Na plus, which coordinates this whole thing, binds like this and binds like this. But that you don't have to worry about. Just need to worry about the product, that is salicylic acid. What is salicylic acid? In the ortho position of phenol, we are going to have COH. Okay, I hope everyone is done.
Yes, sir.
Stop share.
Yes.
Okay, I'll stop sharing the screen and then I will share the test question paper. Okay, please start writing, guys. Okay, guys. So if you will have any doubt, please speak out. Okay. Don't message in the chat. I'm just going away, but I'm still there. I have it in my phone, but if you will message me, I will get it on my laptop. Okay. Just speak out. Even if you're done, if you have any doubts, just let me know. Okay.
Yeah, yes, sir. Okay, sir.